Let's take a look at the octal numbering system. We reviewed a table in class, so I'm not going to go ahead and revisit the table, but let's go ahead and take an octal number and put it in decimal, and then take it and put it into binary, and then back to octal, and then back from decimal back to octal. Alright, so first let's just take this number 246. Okay? And I'm going to tell you that's an octal. We're going to denote that with the small 8 there, subscript. Alright, so we want to go from octal. So right now we're going to go octal to decimal. You know, it's similar with all of these. We're just going to use the base. And the base for octal is 8. So we're going to take here 6 times 8 to the 0. We're going to go 4 times 8 to the first. And we are going to go 2 times 8 squared. Alright, so 8 to the 0 is always 1. Anything to the 0 is always 1. 6 times 1 is 6. We have 8 to the first, which is 8 times 4, which is 32. And we have 8 squared, which is 64. 64 times 2 is 128. If we sum all these together, we should get 166. Alright, so this is our decimal. We denote that with the subscript 10. So we've gone from 246 octal to 166 decimal. Just so we review, let's go ahead and take this decimal and put it into binary. Alright, so remember when we do that, we got to just keep dividing through by 2. So we're going to come up here and we're going to take 166 and divide that by 2, which is, that's 83, and we have a remainder of 0. So now we're going to go 83, divide that by 2. 83 divided by 2 is 41, with a remainder of 1, because 41 times 2 is 82, and we have that remainder of 1 to get to 83. We're going to take 41 divided by 2. That's going to give us 20, and we have a remainder of 1. 20 times 2 is 40. We have that remainder of 1 to get to 41. We have to take 20, divide 20 by 2. That's going to be 10, with a remainder of 0. We're going to take 10 divided by 2. We're going to get 5. Also, remainder is 0. We're going to take 5 divided by 2. 5 divided by 2 is 2, right? Because 2 times 2 is 4. And in this case, we have a remainder of 1. We're going to take 2 and divide 2 by 2. 2 divided by 2 is 1. We get a remainder of 0. And we have to do our last step. We're going to take 1 and divide it by 2. That's 0 to us. And we have a remainder of 1. So remember that this is our MSB, our most significant bit, and this is our LSB, our least significant bit. And remember, we write those most significant to least significant. So if I write this out in binary, it's going to be 1 0 1 0 0 1 1 0. Okay, it's important that we write it in the correct order. So now we can take a look here, and we're going to go binary to octal. This one's nice and easy. We're going to go ahead and group these by 3. So we're going to group this chunk, and this chunk. Just assume there's a 0 in front here. So if we look at this particular part right here, 1 1 0, that's binary. In octal, okay, that gives us a 6. If we have 1 0 0 binary, In octal, that gives us a 4. Or it means 4 in binary as well, right? And then if we have 0, 1, 0, that's 2. Alright, so chunking these in 3, we just take whatever its binary equivalent is. So 1, 1, 0 is 6, 1, 0, 0 is 4, and 0, 1, 0 is 2 in binary. So we can see that we went from binary to octal. We're over here in the exact same number here, 246. Alright, so we went from octal to decimal, decimal to binary, binary to octal. Okay, I won't revisit going binary back to decimal, but what I do want to show you, lastly, okay, is being able to go decimal back to octal. Alright, so we're going to work with the same number here. So we're going to take this 166. Okay, we're going to take 166 and divide it by the greatest common factor of 8 we can get, okay? So we can divide this by 8, 8 to the first. We can divide this by 8 squared. We can divide, that's 64. Anything higher than 64 isn't going to work because it's larger, right, than 166. So the greatest we can divide this by with a base of 8 is 8 squared, which is 64. So if we take 166 and we're going to divide that by 64. When we do that, we get 2.59. Well, we don't really care what this change is right here. We know that it can go in 2 times. Alright? We have to figure out what's left over. Well, we know that 64 times 2 is 128. To get what remains, we have to do 166 minus 128, and that yields 38. So the next thing we're going to divide by over here is 38. Now, we can't divide 38 by 64, right? 64 is too big, so we have to stick with only being divided by 8 in this case. 8 goes into 38 4 times, right? There's a little chunk of change left over. We know that 8 times 4 is 32. So now you have to do 38 minus 32. We can all see that that is 6. Alright? We cannot divide by 8. 8 is bigger than 6. So the best we can do is divide by 1. 6 divided by 1 is 6. And this is usually, you kind of know your ending point once you are under something that's not divisible by 8. So if we can look, we took this decimal number of 166 and we reverted it back to its octal number of 246. So in a roundabout way, we've kind of summed up octal. We've been able to go from octal to decimal. We've been able to take that decimal, put it in binary. We're able to go binary back to octal and decimal back to octal.